All right, we're up to 3-4, day one of two. Skipping 3-3. Uh, just, yeah, so here we go. Pretty short pre-lesson, pretty simple lesson. So, straightforward mathy math stuff. Some of you, elementary school, you'll remember long division, collective psi. Oh. So, a lot of you, maybe you had an elementary teacher that let you use your calculator or whatever. This is just long, grinded out sort of math. So you got to understand this before you can understand what Algebra 2 expects of you. So this is your actual like type of problem, not this. But if you don't understand this, you're not going to understand this. So here we go. Here, you look at this. This is your divisor. This is your quotient. And this is your divisee. You're wondering, how many times is 6 going to 2,745? Start here. How many times is 6 going to 2? It doesn't. So we slide that over. We think 27. It doesn't have to go in there evenly, but 6 times 4 is 24. 6 times 5 is 30. So we want to start with the 4. 6 times, don't forget that, times, we multiply that. We get 24, we put it underneath the 27, and here's a big moment, you subtract. You don't worry about these numbers here. 27 minus 24 is 3. Now, what do? You bring the next thing down, and you start over again. How many times is 6 going to 34? Well, 6 times 6 is 36, that's too much. So 6 times 5 is 30. Don't forget to subtract. And then 34 minus 30 is 4. Because I have one more number to bring down, that'd be a 5. How many times is 6 going to 45? Well, 6 times 7 is 42. Subtract. Don't forget to subtract. We get a 3. Now, I remember back in the day, there was a way you go like this and put a 0, bring the 0 down, and this never ended until you found the final um, um, where actually 6 went into this, where there's no more remainder. But there's nothing else to bring down. This is it. So that would be your remainder. So you would go back in the day, you'd go like R3, you know. So you'd say 457 with 3 as your remainder. That's what a lot of elementary teachers did. Now, this section is going to ask you, hey, what's the remainder for this? Or does it have a remainder? So, or it'll just say divide. So, with that being said, here's the twist. This, we only have one thing out here. This, we actually have two things. All you worry about is the first thing here. I'm going to give you a huge piece of advice. If you have two things here or three things here, slap parentheses around it right away, and I'm going to show you why. But you're going to concentrate on this number, and just let everything just fall into place. What I mean by that is, what times x gives me x cubed? So I'd say, aha, that would be x squared. Now, remember when I put a number up here, I multiply those together, and I got 6 times 4 is 24. Then I subtracted it. Keep that in mind. But now this x squared has to hit that x. That'd be x cubed. These two things should match. X squared times 3 is 3x. I'm just going to 3x squared. What do I do next? I subtract. Now, here's the twist. I only had one number there, 24. This is a representation of one number, but I got to insert parentheses here also to subtract all of it. That's the hard part. X cubed minus x cubed, gone. 5x squared minus 3x squared would be 2x squared. Now, just like we did over here, we brought the next thing down. We're going to bring this, because that's the next thing, down plus 6x. Guess what? You're going to do it again. Start with this, ignore this, look at this, and ask what times this gives me this. That'd be 2x. I put plus 2x, and I do it again. I got to distribute this through both things. So I get 2x squared plus 6x. Now, I'm going to subtract all of this. 2x squared minus 2x squared, gone. 6x minus 6x, gone. But I still have something to bring down, so that'd be plus 9. Now, notice, there's nothing I can multiply this by to get this. So this would be my remainder. Now, some books would have you go plus 9 over your divisor, x plus 3, indicating that this is your remainder. So, but I think this algebra program is going to go x squared plus 2x, and your remainder is 9. All right. I'm going to, so that's kind of the warm-up. I beg you not to skip the sample problems, the example problems that I'm about to show you, because there's a couple twists, a couple different things that happen. And so this is just a warm-up just to kind of get you thinking right, okay? So that's it, you guys.